All right, back and talking about cooling. All right, so, well, because overheating an engine is bad. An engine. What happens when my engine overheats? Too many things.
You make pretty blue metal.
I start to have a breakdown in oil viscosity. When I have a breakdown in oil viscosity, then I'm going to have metal-to-metal contact. I have metal-metal contact. I'm going to increase the heat. When I increase the heat, I'm going to have a vicious cycle with the oil. The cylinders get hot enough, we could have our fuel-air mixture start to ignite ahead of time. That would become pre-ignition, detonation. That, of course, is going to lead to weakened parts, scoring, seizing, not sneezing, seizing. And that's when when a piston swells up to the point where it doesn't move up and down the cylinder. Remember the story I told you guys about the aircraft that took off? The cylinders are bored over and it wasn't quite finished. And the plane took off and said, "Wow, smoke system." And the guy said, "Nope." Right? That engine was seizing up. The pistons were expanding at a rate faster than what the cylinder could handle. The tolerances weren't correct, and so the pistons were actually seizing up in there. So all of that can happen. So I have a whole list of things there, but we don't have time to do it. We talked about some air-cooled engine parts. I'll say parts. We talked about the baffles. Which means proper installation. Engine baffles. We had both the rubber seals and the aluminum parts. We had the cylinder, head temp gauges. We had the bayonet type. And what was the other one?
Spark plug.
Yep, spark plug. A lot of aircraft engines only come with one spark plug temperature. Not spark plug, only one cylinder head temp. That's what I meant to say. Only one. If I had only one, where would I put it? Hottest cylinder. Which one is the hottest cylinder?
Depends on the aircraft and the manufacturer.
It's almost always the back cylinder, but which back one?
The one that's more forward up.
More forward up? So it's not all the way back, but the one a little bit forward?
It's not the one closest to the firewall. It's the one on the other side.
Yeah. So you guys, where's your number one? Right front? All the way forward? 2 is a little bit further back? 3 is a little bit back, and 4 is all the way back. So you're saying not 4, but 3.
Correct.
And it usually is.
But that's for Lycoming, but for Continental it would be different.
Depends on the airframe installation. It really does. But don't think that it's always the furthest one back. It usually isn't. If only one cylinder probe. Place on the hottest. If you had a home built and you built it yourself and you wanted to know which one was the hottest cylinder, how would you do it? Get a 4-probe CHT. CHT stands for cylinder head temp. Get a 4-probe cylinder head temp gauge, or 6 if you have a 6-cylinder. Run it, figure out which one is the hottest, and then take off the other 3 or 5. You would. That's the joke. Or you get a little monkey with a heat gun, and he sits up there. But you got to train the monkey, and that gets hard. Oops. Good. All right, where do we want our ideal cylinder head temperature? Continental and Lycoming are each a little bit different, but if I had to lump it all together, I would say under 400 degrees. So if you're running 380, 390, up to 400, you're okay. You start getting over 400 and you're not so much okay. You got to start backing off. You got to start cooling it down somehow. So how can we start cooling down an engine? Okay, so full rich increasing fuel mixture. Well, there's a lot of talk about that. And your book certainly leads you to believe and talks a lot about how fuel is really a cooling component. So I don't want to lead you away that it's not. What do you think about that?
Crack the.
Well, it cools, but it's double-edged sword.
Yeah. It's not like you're throwing a coolant at it. It's just when you start leaning, you can start doing some other things. So you're supposed to run full rich at takeoff. There's a lot of talk about running full rich on the ground for ground cooling, and we'll talk about some of the myths about that in the back 8 weeks. So that's not quite accurate at all. But you'd be fine to believe that fuel adds an element of cooling, especially at high power settings. So if you're leaning out your engine and you're climbing pretty bad and it starts to get pretty hot, you'd probably want to push the mixture back in and richen it up a little bit. What else can you do?
Reduce the RPMs.
Lower the nose.
Lower the nose would be the first thing. Then you could, back off on some of the power. Yeah, drop the nose, open the cowl flaps back up. If you have them. If not, definitely lowering the nose is one of the first things. Get air coming through there. More air is better cooling. All right, let's see. Where am I here? Cowling. Cooling. I guess we can go out here. That was C then, sure. Cowling. All right, so the cowling, that's everything that goes around the engine. So that's the part you see that makes the airplane look pretty. It's the baffling inside, but altogether I can call it a cowling system. It's a pressure cowling system, which means that when the air comes in, it's under a lot of pressure. It's supposed to be because you have to force it down and around the cylinders. We have high pressure, low velocity on top. Usually, not always. What if I have an inverted like a Ranger, inverted 6-cylinder? Then it's going to run the opposite. So high pressure is going to come in the bottom and work its way up the top. Let's see, low pressure. High velocity on bottom. Cowl flaps, those are at the bottom. I drew the little drawing for you guys. So I should say most aircraft. There are many aircraft out there that don't have cowl flaps. They just have a little lip on the bottom that creates a little venturi. Nicer airplanes, the nicer they get, the bigger you get, the more horsepower, they'll have adjustable cowl flaps that are going to go up and down. So if you do have adjustable cowl flaps, let's see. There are manual, electric. So you have manual, which is just a handle. You go up and down. There's electric, which is a little, same thing, just a little switch, goes up and down. And there's even some that are automatically controlled by a thermostat. That, hey, when the engine is getting hot, they're going to open up. When the engine's cold, they're going to close. So we have all of that. Let's see. Let me see. Oh, there's so much here I'd love to talk to you about. Maybe you'll get it next semester, or next year. Rigging is a big deal. These cowl flaps are taken, it's kind of a, we're thinking about engines right now. So as an engine person, I'm always going to look at cowling adjustment and make sure that it's properly rigged. Now, in other words, when the pilot selects open, this actually dropped down to the full open position where it's supposed to be per the manual. Now, airframe people are like, it's the engine part. It's not really a flight control. So open's open, closed is closed, and they don't care. So I actually would check the rigging on them with all my engines. Hey, I want to know when they go open, is this the proper degrees open? When they go closed, the proper degrees closed. So it's a good idea to check rigging on them. Operation. Sorry, I kind of screwed up. Check. Rigging. They should be open during ground run. As mechanics, you will be actually involved in ground running engines. So you get into the aircraft. One of the things you want to do is check and make sure that the cowl flaps are open before you start it up. Usually closed in cruise, which means they're probably open during the climb out. Don't have to be, but let me see, cowl flaps, cooling fins. Should always inspect for bent, broken cooling fins. And I'm just going to say refer to manual. Or service bulletin instruction. I'll be honest, out in the field, every time I had to deal with a bent, broken, or inspections, I always had to take out the exact engine manufacturer bulletin. It's just something that they're so different, Continental and Lycoming, that it's difficult at best to memorize these. Let's move on. All right, pressure baffles. I'm going to move away from writing here, and I want to talk to you about these pressure baffles. So, as a mechanic, you really do spend an awful lot of time dealing with these pressure baffles. They wear out, they go bad, they're neglected, nobody cares, until a pilot complains about them, and then suddenly you're like, wow, I got a lot to do. So one of the things I did is I made it a point when I did annual 100-hour inspections was to let the pilot know, hey, the owner, you've got some baffle problems here. Is this something you want to take care of? A hot engine is going to, it's going to wear out much faster. Usually one of the first things that's going to wear out, let me ask you guys, what's the hottest part of this engine that's running? The head, cylinder heads, what specifically? Exhaust valves, exhaust valves. So if you're not cooling down your exhaust valves, and they're running hot, they're running up above where oil's already going to coke, right? So if you put too much oil through there, the oil's going to coke. The longer the oil sits there and bakes, the more likely it's going to be coke. If you coke the oil inside of a guide valve, what happens? Starts to get sticky.
Morning sickness.
Right, it starts to get sticky. You get a valve that sticks in the guide. Best case scenario, you've got some morning sickness, and you catch it, and then you have to pull all the valves, ream all the guides. Worst case scenario is you stick a valve and you bust the push rod, tap it, break a tap it, damage a cam. Now to change out the cam, what do you have to do?
Open the whole thing.
Take the whole engine apart. Now, once you get the case open up and you've got a Continental 6-cylinder, you're subject to the ultrasound inspection. So now you got to take all the rods off, so you can clean the crankshaft, so you can do the ultrasound inspection that's required. Well, now at that point, you're building it back up. What do you need? New rod bearings, main bearings, rod nuts, rod bolts. It just starts from there. At that point, you're like,
might as well do an overhaul.
there you go, from a stuck valve. So, you do yourself and your customers a favor, and you inspect these areas that are so highly neglected. Unless the temperature gauge is showing something negligible, most pilots don't really kind of equate it, unless they're really into their own maintenance. They just kind of like, runs cool, what do I have to worry about it for? But this is a beautiful installation right here. It really is. So there's a couple of key points. One, this rubber seal, notice how it's folded upwards. And the reason why it's folded upwards is because the air is going to come through here and push against it. And if it's pushed up, it's going to push up against it and form a seal against the upper cowling. And the back is folded down and forward, and it's going to do the same thing. And if you look right here, you can actually see a line that's running right along there and you probably can't see it up inside here, but this line right there, that's where this baffling is rubbing against. And so I'll always look at that and see how the baffle is riding up against. I mean, this is a gorgeous installation. It's been freshly painted up there. Looks like a brand new propeller. So that looks actually pretty nice. These are cowl flaps right here that are open. Oh, yeah, got a lot of them. Here's one that's fixed. So that's just like a Ronca or something like that. Oh, it looks like a Luscombe. I think it's a Luscombe with, I didn't notice before, but a little wind-driven generator down there. These are adjustable cowl flaps. So like I'm talking about, you have to make sure that when it's open, that you actually have all of the proper gap and everything is on there. It's important. All right, so now we get into the don'ts. Hate the don'ts. Here's my first don't. Well, right on the dang engine. Looks terrible. What's 70 mean?
The pressure, when they did the compression.
Did a pressure. What does R mean?
It's a bummer.
Yeah, probably leaking past the rings. 74. That's terrible. Anyway, that's not the subject we're on right now. Just don't do that. All right, so this baffle is now, it wasn't folded up, it's folded down. So what's going to happen? All the air is going to come right over here and leak right past here, like that. All right, horrible little seam there. The whole thing is bad. So that baffle is all wore out and needs to be replaced, it's common maintenance. That's terrible. But here's the oil cooler right here. Oh, this must be the other side of the engine. I recognize that writing actually. So, yeah. No, it's actually, these are out of, I think, an FAA website. I think this is Continental Service Bulletin, actually, of what not to do. Right there's the oil control valve. There's the oil cooler.
Yeah.
So all of this is nasty. That is not appropriate.
It's got to be the worst when your work is said not.
Don't end up Continental's improperly positioned baffle seal service bulletin, please.
Yeah.
So it's idiot resistant?
Yeah, it's not. Baffle's actually hard to do. Okay, so this is looking at the back of the engine. And so all the air is going to come up and press against this on the back. And this is actually quite common. So it's really hard to get, of course, metal sealed to go nice and tight around everything. Here's a magneto and here's a magneto if you don't know what you're looking at. So this is probably the same engine looking at the magnetos go forward in a big Continental. But all of this right here, it's air leaks. Now, like I said, that's really kind of common. You got an air leak up here, and then the rubber seal is going to be right up in here. So what I do, and I did in my own engine, it's not pretty, but it's better than, I'd rather not ruin my engine, is I actually got some high temp RTV, silicone sealant, right? RTV stands for room temperature vulcanizing. And it comes in orange and is the only color it comes in when it's high temp. But I actually sealed all of this up in my airplane. And I would do it for my customers too. And so once that's all sealed up, that's all that much more air that's going to be forced around the cylinders.
It cools
Kevin,
better after.
why would you use that sealant instead of maybe putting more of the baffle seal there?
It's almost impossible to get it in here because you have to. Baffle seal is not a fun job. You have to cut it to size, pop rivet it in place, and then you'd have to drill a whole bunch of holes here and pop rivet it. But you could, you really could. If it was your own airplane, you wanted to take the time to do it right, you really could. I chose to do that because I could get it done. And I'll tell you a trick that somebody taught me is get a little isopropyl alcohol. I wish I would have known this when I was in the industry because I did it that way. Spit works. But if you have a little cup full of isopropyl alcohol and you put silicone on anything, dip your finger in the IPA and you can wipe it, and it looks like a machine did it. It is gorgeous. People will be very impressed with your IPA skills, or your silicone skills, I should say. Oh yeah, and then also things like this, seal that up. So start sealing all that up. See, oh, that looks better already, doesn't it? Works better already.
Hey, Kevin,
Huh?
do you mind just turning the light on the
This.
on
The
the LED light.
Document.
Oh, document. Turn off the document camera.
Thank you.
There. Okay. I was going to say, what's wrong with this one? Well, it has improperly positioned aft and side peripheral baffle seals, as you can tell. It's pushed down, and it's wore out. So if you think about the fact that this is the edge of the aircraft, is this even going to be touching the baffle, the cowling?
What is the baffle made out of?
This right here,
Yeah,
rubber.
it's rubber.
Yeah, it's group. Okay, so you guys that are hanging your engine right now, those orange washers, it's baffle seal material. That's all it is. So it's like a lot of times it's two pieces of rubber sandwiched with some sort of cloth in between. You can buy it either in a roll. Roll's about that tall. And a roll of it, or you can buy it in big sheets of it. So the nice thing about sheets is you can actually cut it around, to a size. If it's a roll, you got to kind of make it roll around the corner. When you do that, of course, when you roll in a corner, it doesn't want to lay right, but you can get it to fold up, and then it's fine. Honestly, if you can work on an airplane where the cowling just fits just right up and right on, you can screw it all together, and you didn't say any bad words the whole time or say, I hate this cowling, your baffle seals wore out. You should, literally, you should be fighting it the whole time. If you're fighting it and you feel like a come along would really work well, where you can, put it around the engine and ratchet the stupid cowling on, that's a good seal. And that's kind of what you want. And what's it going to do? It's going to look like that. So it's going to rub and create wear marks, and it just does. That's just life on your cowling. But right here, it's showing these dirt trails going through. So what problem do I have right here? Got a bunch of blow-by, all those leaks.
Is it vulcanized rubber?
I don't know what planet it's from. I'm sure it is, yeah.
Rubber material, they're not formed parts that have part numbers, each one of them, or?
I wish. Life would be great. And I bet that if you could come up with something like that and sell it, you'd be probably
Millionaire.
you would have wasted a lot of money because there's not a pilot in the world who paid the extra buck for it. Mechanics would love it. And I saw this picture on the internet. I thought, oh, that's just gorgeous. All right, so what you're looking at right here, this white piece right here, so that's a piece of the inner cylinder baffle. So that's actually holding, I wish I could show you the bottom side of it, which reminds me that when you hang your engine on the test cell, the test stand, I feel sorry for those who will forget this, is the inner cylinder baffle is pretty much one of the first thing that goes on. You can put the sump on, but then everybody wants to put on the intake tubes, and you can't get it through the intake tubes. So you have to take the intake system back off. So your next move should be to put the inner cylinder baffle on. And I can show you how that goes if you need help. But anyway, so there's all that inner cylinder baffle is in there. Notice how this front cylinder right here is actually protected from the air coming right in, because then it would create, it just gets too cool right there. So you need to warm up a little bit so it's all protected and then it flows over. And look at what they have right here. Whose idea was that? Hannah, can you see what that is? All this blue?
They asked me how to do it.
They asked Hannah how to do it. And does that look so much nicer than some guy with a tube of caulking? This is why you should have her install your engine, not me. Yeah.
Why isn't the cylinder across from that one have the lid above it?
Oh, why doesn't this one go all the way up and over?
Yeah.
Probably because of the rotation of the prop.
Okay.
It has something to do with it. I do not know. Some engineer figured out that that's the way it needed to be, and that's the way they went with it, even though the prop's going this way. Augmenter tubes. There's some questions about in Q&As about what is an augmenter tube. This kind of works to explain it. An augmenter tube is like a venturi in a way. I can't think of any other things that you'd be familiar with. In the Navy, we had things that actually were firefighting. They would eject water out. But what's happening here? Oh, this reminds me of a story. So I bet my son I could inflate an air mattress faster than he could. All right. So I said, "You go first, son." So I got my watch out, and he got the air compressor and the mattress, and so he figured his trick would be he put his hand over the inflator valve of the air mattress, and he stuck the thing in there, got as tight as he could, and he go, and he squeezed it and he filled it up. All right. And I said, okay, now my turn. Of course, he's thinking it's all about who can make the best seal. But I've got the air mattress, inlet right there, and I take my air gun and I point it about like this at the air mattress, and I inflated it at least twice as fast as he did. Why? Because the air stream coming at that inflator draws all the air around it. It creates this low pressure right here because of the high velocity air. Created, who do we call this principle? Venturi and Bernoulli's principle. So that air rushing in created a high velocity, which created low pressure, which drew all the air around it and pushed it in with it. So I inflated it significantly faster than he did. And that was the last time that I ever beat him on anything. But, because then he turned 6. And, all right. So the same thing is happening here. So these are the exhaust nozzles out of, well, it says that exhaust. And so what's happening is it's shooting the exhaust out this way, but at the same time, that's now creating a low pressure area. And that low pressure area is drawing the air from the top or bottom of the cowling? Bottom of the cowling. So it's creating that low pressure air. Same thing as if it had a little flap on it, a cowling flap. So that's what an augmenter tube is.
So wait, is that pointed towards the trailing edge of the wind?
Yes.
Okay.
Yes, because it's going forward, it wouldn't work. So. And what is this?
R22 engine.
Is a helicopter. How are helicopter engines cooled? With a big old fan up here. It is not cooled by the rotors or anything else. So it's like a Volkswagen, right? Of course, you don't have a Volkswagen, you wouldn't know that. So, right? Is it Volkswagen technology?
Oh yeah.
Okay.
Kind of, yeah.
Kind of. All right. So the fan's got to be working at all times. The fan draws in air, blows it over the cylinders, and that is how a helicopter is cooled. Helicopter. What is a helicopter? It's a million parts rotating rapidly around an oil leak waiting for metal fatigue to set in. It's funny because it's true. And I don't have time to go into running an engine, so I'm very sorry about that. That's what that's all about. So you can see the pictures that I'm not going to talk about.
Well, we do
Yeah.
it in the next day.
Those were your plane, right?
Yeah, simulator. All right. That doesn't give us much time. So let's review a little bit, because we covered quite a bit, spanning 2 weeks of time, or a week and a half. Didn't even give me time really to get into water cooling. There are some aircraft that are water cooled. They're actually, Continental tried it with some of the smaller engines, like I think there's an O200 water cooled version, where they actually put water jackets around the cylinder. And so if you just put a water jacket around it instead of air, you can just flow water across it, which is, it's the same concept. Our 172 out there has a diesel engine in it. It's water cooled. All of your cars, not all of our cars, but most of your cars out there are water cooled. And it's the same concept.
It adds a lot of weight, right?
Okay, so what are the downsides of water cooling? Well, you're definitely going to add weight, because now you have to have a water source.
Oil contamination.
You've got potential oil contamination. With if you have a seal, water could get into the oil back and
Call
forth.
it chocolate milk of death.
Yes. Okay, so we've got extra weight from the coolant. We have to have hoses and tubing to transfer coolant. Anybody ever have a coolant hose break on your car?
Yeah.
Really sucks if you're over the mountains at night, IFR, wouldn't it? So that's a bad thing. So we add that complexity to it. Water pumps leak and break down. So all of these things that can break down. The other thing is you have to have some sort of heat exchanger. So really, your water-cooled car ultimately is an air-cooled car, because what do they do with that water?
Radiator.
You go through a radiator, and what then takes the heat out of the water? Air. So an aircraft, we're just like, hey, let's just cut out the middleman, and we'll just go air over air. So you have all of that problem. The upside to water cooling is you can control the temperature to a much finer degree, which means that you can run closer tolerances. And if you can run closer tolerances, then you can make a little bit better of an engine. But otherwise, it's too complex.
Isn't there additional drag from
Oh, I was gonna say, yep. And then you have to hang a radiator down into the because the radiator's got to be much bigger, so you got to hang that down into the airstream, which adds drag. Or you could use a NACA duct or something like that.
Are the water-cooled engines made with tighter tolerances and made better? Or that's just you could?
Well, I don't want to say better, but yes, water-cooled engines have closer tolerances. They're allowed to run closer tolerances.
Do any engines nowadays use evaporative cooling?
Evaporative cooling, where you just,
Where they have the radiators on the wing?
not that I know of.
I would think that'd be a lot of tubing to put the radiator on the wing.
It is, but it's lighter. You got
All right, let's see.
You have more possibilities.
Well, first question is, boy, I didn't have a chance to talk much about grease, did I? And my first question on test about grease. But we did talk about EP. What does EP stand for in grease and oils?
Extreme pressure.
Extreme pressure. What is synthetic oil made from? Animal, vegetable, mineral, none of the above? None of the above. What temperature, what is that called when oil undergoes oxidation and forms crystals?
Coking.
Coking. And what temperature does that happen at?
130? No.
Like 300
300 what?
Fahrenheit.
Celsius.
Do I hear another answer? Which is hotter, 300 Fahrenheit or 300 Celsius?
Celsius.
I believe it's about 570 some Fahrenheit and 300 Celsius. So 300 Celsius. What about specific gravity? What's that compared to what? Distilled water. So does oil have a higher or lower specific gravity? So will it float or sink? Float. Okay. What's aircraft oil weigh?
6 pounds per gallon.
That's what aviation fuel weighs.
No.
Avgas, to be specific.
8 pounds a gallon.
8 pounds a gallon. That is very close. 8 pounds a gallon. Can we get closer?
8.4.
Well, we'll go 7.5. 7.4 would work. 7.5. 7.5 pounds per what?
Gallon.
Gallons. All right. What does flash point mean?
How hot is the substance has to get before enough evaporation happens before it can catch fire.
And maintains the flame.
Catch fire and maintain a flame. That is called
Fire.
fire point. So what is flash point then?
Sparking.
The same thing, but it just flashes and doesn't produce enough to sustain a flame.
All right, so flash point means you'll lose your eyebrows, and fire point means that you will.
Lose the layers.
Okay, lose. Yeah, there we go. And what happens to the viscosity of oil as the temperature goes down?
It
Increases.
It increases as temperature goes up. It.
decreases.
What was that called when there wasn't a big change between the two?
Viscosity index.
Viscosity index. Did it have a high or low viscosity if it didn't change much?
High viscosity index.
All right, that sounds good. All right, so I'm going to fly my Cessna 150 up to Alaska. I'll be back by tomorrow, but it's going to be really cold there. Actually, I'll go to New Hampshire.
We'll be back in about a week.
Back in a week. Well, it's my 150. If I flew to Stockton, I'd be back in a week. So, all right. Point being, it's going to be very cold there, and I'm worried about my oil congealing when I start up. So, what solution do I have?
65 weight.
Go with a lighter weight oil.
Get fuel.
Mix it with what?
Fuel.
Gasoline.
Gasoline. So I better hope I have an oil dilution system on my airplane. It was never an option for a Cessna 150, but that's okay. We can pretend, right? So, all right. So oil dilution system is going to inject what?
Fuel.
All right. Or I could just, I guess, open the oil filler cap and put 5 gallons in. What's going to happen to that fuel as I go flying, take off in the morning? Okay. And if I could somehow light the yeah, if I can somehow light the vapors off, I could have an afterburner.
I get to see that.
Yeah. Okay, so on aircraft engines, you have a breather. What's the breather do for you?
It ventilates the blow-by gases.
Okay, ventilates its overboard. So one of the things about, I won't draw the whole engine here because, well, got the flange, got the engine. All right, so we got a breather right there. That usually has a line that's run towards the back, up to the firewall, and then down. So you got a little cut like that. And that hangs down a little bit below the belly of the aircraft. And believe it or not, they actually put this funny little thing right here. It looks damaged. So if you ever see one, you'll see that looks like somebody pinched it right there and damaged it, and there's a little hole right there. So I can't draw it well, but it just really looks like somebody bashed it with a hammer. Just whack, dented it, and put a hole in it. That's called a whistle slot. Care to guess what the whistle slot's for?
Stupid siren.
Huh?
Stupid siren.
A stupid siren?
Stupid siren.
Stuka siren? I don't know. Sorry. The whistle slot is up high enough inside of the aircraft engine area that it stays warm.
For ice.
So if you get ice that blocks this up, it stays warm up here all the time. And so the fumes that come out this way and go out that way. But in a normal operation, they don't want to go that way. They go out the belly of the aircraft. So that's a whistle slot. What kind of oil are most aircraft manufacturers going to recommend for break-in?
Straight
So no. Then after that, what are you going to switch to? And how is ashless dispersant identified, like by aeroshell?
W.
Okay. What does the term ashless dispersant mean?
It means that if you took all the additives in the oil and you burned them in a jar or whatever, you
A
would,
jar or whatever.
a beaker, you would get no ash from
Okay. You are correct. What does SAE stand for?
Society, automotive.
Society of Automotive Engineers or enthusiasts, I don't know. Engineers. And so SAE 50, if I had SAE 50 oil, what is that in aviation grade?
25.
What is SAE 50
Sorry.
in aviation?
100.
100's correct. What happens if I use oil that has too low of a viscosity?
Oh, you'll burn oil.
Not enough coolant.
It'll have more metal to metal contact because it won't have the viscosity or the tension to hold it from the bearings. It'll go by the rings, so you
Too
burn
thin.
oil.
It's too thin and it's going to give you metal to metal contact and you're going to have wear and that's going to be bad. What happens if I have an oil that is too thick in viscosity?
Won't be able to carry or
It's not gonna
push through the
disperse.
system.
It won't push through the system, so what happens?
High pressure.
Goes by the.
Metal contact.
Metal to metal contact. If it's too thin, too thick, same outcomes. How are the conrod bushings on the piston pin end lubricated? Drip oil? Where's it dripping from?
From the main bearing.
From the main bearings? How from the main bearings?
Through a hole.
Goes through the concrete.
Connecting rod, piston pin, bushing.
It goes under.
Does it go through? Nope, no holes in the push rod. Or this isn't a push rod.
Splash and spray.
On yours, there's a little hole here, but that's pretty rare. Usually they look just like this. Splash oil is correct. Where's it being splashed from?
The journal.
Broad journal splashing around, back of the piston. How are pistons?
There's actually a jet on some of them.
Well, what is the? Well, if I told you what the name of it was, you'd know what it was. How are pistons cooled, generally speaking?
Oil.
From what?
Oil.
Oil spray. Where does the spray come from?
Jets. Little spray.
Lycoming uses, on some engines, uses piston cooling nozzles that will literally spray right behind it. Where Continental drills holes in their rod caps, they'll spray, or otherwise just splash going around. Okay, I've got a couple questions about what kind of oil you would recommend. It's multiple choice, so I don't make it too difficult. But basically, it's give you a kind of a temperature and a high temperature, what kind of oil you want. Low temperature, what kind of oil you want. For example, customer wants to fly their brand new factory overhauled 0320 in 0320? Yeah, 0320. Tomorrow. Kind of oil you want to put in? Straight weight, straight mineral?
Well, it's a freshly overhauled.
Okay, so mineral. So you want to go, what weight?
Probably about 80.
You want to go 80? Okay, so your choices are 80 or 100. You want to go 80. You want to go W80 or straight 80? Straight 80. All right, let's make that a TIO 360.
W80.
W80. Why W80?
Because it's turbocharged.
Turbocharged. All right. Let's see here. A couple of troubleshooting questions about oil pressure being too low at idle, high at operating temp. What do you do? And what about that engine that was overhauled? 50 hours later, comes back and says, hey, what kind of oil do you think I should use in this thing? Well, give me a brand. She says, I want to run straight weight in my Lycoming.
Aeroshell W80.
W80 plus. Why do I want to run the plus?
Cause that has the additive.
As the additive that Lycoming wants. There you go. So W80 plus. Don't forget about that. Where's the oil temperature of a dry sump engine taken?
Right after the pump.
If it's after the scavenge pump, where's the oil headed to?
To the cooler.
Then it's right after the engine, right? And that's going to scare people.
Which goes right before the engine.
So,
The outlets,
outlet of,
the
pump.
The oil pressure screen.
okay. So, after the oil pump or before the oil pump? Let's see. After the oil pump. Okay, I like that one. What's normal cylinder head temp?
400.
maximum.
Under 400.
Under 400. Not 400. 400 is a little bit hot. So under. So if I said like under 100, under 200, under 300, I would hope you'd pick like under 400. Not ideal. Yeah, that'd be too cold anyway. All right. Okay, so there's 25 questions there, and I think another 25 on the Q&A. I know we kind of rushed through it. It was a little too much to bite off for a week.
Kevin, I had it at 460 when I had that going.
You had what?
I had it at 460.
Oh, 460?
With the red and flashing.
Dang.
400 miles off road.
Well, I don't write on the board anymore, but my tradition is, I'm done. So that's it for me for 4 weeks. So test tomorrow.
So long,